Right. This is where you find the hardcore conference goers. Last session of the day. And this is the special one. So Omkar and Abhishek are in grad school, and this is their final year project. And we can thank their mums and dads for paying their flights to come all the way to Amsterdam from India. And they're going to give us a demonstration of the power of open source and the internet for two guys in India downloaded a cluster and built a product, and it's part of their final year project. So without any further ado, guys, over to you.
Good evening to everyone. My name is Omkar Nibande. I'm a final year graduate student. This is my partner Abhishek. He also works with me. So today we are here from India, going to present smart meter data analytics. We use Hadoop for it, and basically starting with the topic, I would like to introduce the topic, as in why smart meters and all. So as I told, I'm a final year student. We do have to present a topic and work on it annually. We have been working on this topic for last 8 months, and there is a very limited time to do all the work, and so whatever we tried, we are here to present it, showcase it. So the final year project, yes. What we had in our mind was to do something related to big data, and our relatives helped us to gain more insight with some real-time problem. And what we found out, that energy, that is electricity, is the main thing, and we should be focused and worked on. The distribution pattern of energy should be more precise and should be more accurate than what it is. Like we compared the developed as well as the developing countries, some some surveys related to that were done and were found on the internet, and we found that more work should be done. Like in India, there are power outages and certain issues. The power outages are for 16 to 18 hours, and working on it, we found out the solution to this might be smart meters. So we started learning about smart meters. So why smart meters and why smart meter data analytics? Basically, if we start that smart meters, most of you know smart meters. So can I just, some people raise hand, means to the one who knows smart meters, raise hand please, once. Yeah, okay. So smart meters, they send a structured format to the server or the pre-located designation through the internet of what the user is using, of how much data the user has used. There is a fixed timestamp and the amount of data, amount of electricity the user has used, and after gaining such data, we can process and do the analytical part, which will be beneficial to two segments, basically the customer as well as the service provider. We took into consideration many factors like the service provider. There are multiple service providers in some countries, while in India there is only one service provider, which is the government, and the government is controlling all the electricity distribution. So knowing more about electricity distribution, the main problem with electricity, what is basically came to know is electricity can't be saved. Like it's not a bank where you can save electricity today, which is produced currently, and utilize it tomorrow, because no batteries or inverter do provide such facility like saving the electricity and using it later on. So what the smart pattern of distribution should be developed and it's used should be main focus, and it will create more business power and add more value to the customer segmentation and the service provider also. And how do we gain this? We'll be explaining throughout the session. So again, coming to the basic point, what are smart meters? Basically everyone knows the house and industry, everywhere we install smart meters, and they do send an MIF, that is metering image format. Whatever the structure of metering image format, we'll look at it later on in the slide. So this is basic animation you can see on the screen. What the smart meter and what the MIF contains, it stores a timestamp and how much data is used by the customer or by the end user. So we are doing this smart meter work. There are some advantages. As previously told, there are two patterns, the two segments, customer and the service provider. The customer is not at all concerned with what the distribution board is doing or what it takes to produce electricity and to distribute it, and what all things go in between. The customer is only related to money and he wants to save his money. So the billing accuracy and the customer usage pattern should be plotted in the BI tool. The usage pattern, like the customer will be segmented. Accordingly, the surveys will be taken, and we found out some surveys which state that there are customer segmentation previously done but are not related to the smart meters. They are not exactly plotting what surveys were taken and what smart meter data is consumed. Like customer segmentation pattern, there are nuclear families or the families having different age people, like the teenagers, the old people, but there is no relation of such data or such factors with the relation to the smart meters. So taking this into consideration, a segment can be formed where a customer living at site A, whether he is belonging to, say, suppose nuclear family according to the survey, and customer staying at site B. So these both, if they fall under the same category or the same segmentation, they should be consuming same amount of electricity. Approximately same, but if there is a vast change, then certain things need to be followed, and to bring down the energy distribution, means to linearize what energy distribution should be. Talking more about customer advantage would be billing accuracy, as it's the basic factor of smart meter. Billing accuracy will be very efficient and very approximate. Now coming to the service provider, as I told previously, there are multiple service providers in some countries, whereas there is only single service provider in some countries like India. The demand response, time of use tariff, and load profile analysis, these are very big advantages and will be explained one by one later on. The theft detection and billing accuracy, in short, I will say that the theft detection can be done. What we both did, we visited the local distribution boards and found out from the very beginning, from the generation of electricity, from thermal plants to water things to distribution. The thermal plant generate electricity 24 hours a day, but whereas there is no consumption of electricity during nights, like from 12 to 4. No one uses electricity, and in India basically that time slot is given to the farmers free of cost. They do use electricity free of cost, but this is not fair. Means the consumption is restricted to certain hours. There are peak loads, like if you consider the case of industry and combining industry with customers, like the normal residential customers. What we come to know is residential customers do not use electricity or the utility during the daytime. They do use only during the peak, means they can start consuming it from the evening 6 to 8 or 6 to 10, and whereas the industry, it continues from the daytime and till night. So there are peak loads which can be plotted out like from 6 to 8. This is a very peak load where the residential and industrial load starts up, and there is a huge demand of electricity. So these things a service provider can come to know through this, and a smart distribution can happen. Moving on, the smart meters, yes, the MIF file comes on. MIF is metering image format. The rate generated, it's 15 minutes, and say approximately 3000 readings per month per user is generated by a smart meter, and 1 million meters will generate 36 billion readings. 36 billion is a huge data, and if we say one MIF, a standard MIF is of 20 bytes, this generates a data, a very huge data which should be computed, and this statistical data is taken from IBM's paper, and there is a 13% annual growth, and there are about 460 billion smart meters which are going to be installed till the end of 2015. So computing all the data which has been generated by the MIF, The solution is, of course, yes, the fastest computing, Hadoop, and there are some features like massive scalability and all, which will be covered by the Hadoop. Coming back to the advantages, the demand and response. So basically, what demand and what response. So once a customer or any segment starts his utilization of energy, there is a demand, and there are peak loads, and there are general time. There is a general time when no one uses electricity. So predicting what the demand is and what the response should be given, like the thermal plants will generate electricity 24 hours a day, but there is only demand during some hours of the day, like from 6 to 8. What has came in our survey, it was 6 to 8, so I am repeating that time 6 to 8. The response should be very accurate, or say if there is demand only of 100 kilowatts, say for example, only approximately 95 to 105 should be produced, because electricity should not be wasted and it cannot be saved. So basically linearizing every duration of the day to match the demand and response should be done. The next benefit was time of use tariff. The time of use tariff, as you can see, it's very related to prepay phones. Most of you are using prepay phones. We do get schemes like low calling rates at some hours, high calling rates at different hours, and we do use our tariff. Basically, that's done as from the customer point of view. We just get to know that yes, I'm getting benefit, but actually it's reverse case. The network is having no load, so they do offer you certain advantages, and they force you to run your things, like they will give you certain facilities like do SMS at certain hours or certain days. That's because the network, which is capable of doing many things, is idle, and so they are forcing or manipulating you in a way to turn it out and use the electricity, use the schemes. Similar pattern can be done in electricity. People are unaware that they use certain devices at any duration in the day, and they do not think that electricity should be used at that point or should not be used at that point, because it's a peak load time, peak load duration or no. So we cannot go in any of the home and say turn on or turn off, but what we can do is basically create tariff plans which will make customers move from utilizing energy from one period to another period, and this will be beneficial to the service provider. From a customer point of view, if we think a customer is giving his own analysis, or he's provided with certain things like at certain duration of time or certain hours, a couple of hours, there are peak loads, and we can manipulate him to shift his time from that load to some non-peak load, like he can use his normal course like washing machine and all. He can use it in later part of day instead of using it at peak times. So basically this is time of use tariff. One more benefit for this will be from the service provider point of view. Like service provider is providing electricity 24 hours a day, but he is providing it at the same rate, say €1 per hour. But there are peak loads, and where he will be providing the electricity at same rate, whereas if he changes his tariff, he can gain more benefit at that peak load. So this is basically what time of use tariff, which will be advantageous. The load profile analysis and rest of the things will be explained by Abhishek.
Good evening. I am Abhishek Korpe. I am a student from Wadia College Engineering, Pune, from India. So basically, what is load profile analysis? So load profile analysis is just a chart in which the time versus load charts are drawn. In this, we can find out that whether a customer, for customer behavior, we can find out what types of, how the usage pattern is changing. A particular customer can find out his usage patterns such that if I use my washing machine in this time, he said time of use tariffs. If I use my washing machine this time, I can reduce my consumption and I can pay less for the energy that I use. Then from the utility point of view, we can find the particular utility company can find out the usage patterns of a particular area, in which times the peak hours are there, which time the customers use less energy. According to this, many business plans can be made. So load profile analysis is basically used for designing a business intelligence decisions such as time of use tariffs. Moving ahead. Yeah. Now what we have actually done. Now this is a data flow diagram of a system that we have implemented and that is running in our college. We can see that smart meters. The smart meters are pre-configured to send a data every 15 minutes to the server. Now the data that is coming on the server is on the local file system and not on the HDFS. So this streaming data that is coming from the smart meters is taken from the local file system and then put onto HDFS using Flume. This is done at regular intervals of half an hour. So the data that all is coming is put into HDFS. Now the data that resides on HDFS is using MapReduce jobs. It is the data is processed, cleansed, and the important data that is available is taken, and that is used for generation of charts. These charts are then put into dashboards, and these dashboards are used for taking business decisions. Now these dashboards can be used for making predictive analytics. Example being if a particular utility company can predict a particular demand at a particular period of time, so that will save most of the it will save the cost for the energy demands. As energy, some utility companies buy energy from other utility companies. So at the during the if the utility company buys the energy at a very early stage, it can save a lot of bucks. And secondly, load profile analysis. We have seen what load profile analysis is. Now this is the overview of the cluster, the 21 node cluster that we have set in our lab. There are 21 machines with very medium configurations as 2 GB RAM, dual core processors, and 150 GB of hard disk. There are 3 masters. The slave one, as you can see, is the name node. The slave 2 is the secondary name node, and the slave 3 is the job tracker. So this is a total 2.5 TB cluster that we have set up in the lab 412 in our college. This is the photo of the lab. These are some screenshots of the name node. See, we can see the 18 live clusters. Everyone would be familiar with this, but the configured capacity is 2.5 TB. Yeah. Now let us come to the input file that we have. This is a screenshot of the input file for our system. This data we have got from the Irish Social Science Data Archive. We have on contract basis, they have given us the data. This is a 2-year data of 5,000 meters taken at 30 minutes intervals. So this data is around about 2.5 GB. Each record is around about 20 bytes. Let me explain the format. The 1392 is the meter ID of the particular meter. The next 5 bits are the standard decoded format for time and date. The 195 stands for 15 July. It is in the format of 001 is 1st January 2009. In that way, 002 is 2nd January 2009. In that way, 195 is 15 July 2009. And 01 stands for specifically the period 12 o'clock to 12:30 is the first slot. So in this way, 01 stands for the slot between midnight and 12:30. And last is the energy, total amount of energy consumed in that slot. So this way, this is the most basic structure that and this is minimum structure that should be sent to the server by the smart meter. This is 20 bytes. But when we surveyed in India, and in some regions in India, they have smart meters. That is not only a state hazard. So in that state, they calculate this. The smart meters even send the data of the voltage levels, the power levels, the current flowing through 3-phase meters. So this data that is generated is sent to the, and that is the format is 166 bytes. That is almost 8 times. So making a quick calculation for a 1 million meter, that sums to about 80 TB of data that needs to be processed. For 1 million meters, 1 year is 80 TB of data. So this is huge data. That is why in picture comes Hadoop. This is not possible for traditional RDBMS. It is possible, but in the sense it will take longer time. A decision taking 10 hours, query to run takes 10 hours in traditional RDBMS, but wherein as Hadoop it takes 4 hours. So decision making process becomes more faster. Now here, this is the output of one of the outputs of a system. As you can see, the red circles, they are the predicted outputs for the month of January. We have 2-year data we simulated to make it for 10 years, and then we ran the job. So for the 11th year, this is the predicted output using statistical methods that we have generated. This is a particular range in which the demand will be ranging. So for a particular utility company, this will be more useful for predicting a month's data. So buying for them in advance will be more cheaper, so they can save a lot of bucks in there. We ran a test job, and this test job took around 11 minutes 15 seconds on 10 GB of data on an 18 node cluster. And after this, we ran a job using the combiners, and the amount of time reduced was from 11 minutes to 2 minutes. So using combiners, we can do more easily. Now let us come to the future scope. First is the customer segmentation. Using the smart meter data analytics, the utility companies can focus on customer segmentation. Customers can be segmented on the basis of whether it is an industrial customer or a household customer, the amount of energy it is using. On the basis of that, how many people are staying in the house, if it is a household meter, how many people are staying, the geographical location of the meter. All these various parameters can be taken into account for this customer segmentation. Now customer behavior. Now coming to customer behavior, this is an interesting point. The customer himself can analyze his behaviors. Example, a time of using peak loads. If a customer is switching on his washing machine during the peak hours, he is spending let's say 6 rupees, and if he just shifts that to non-peak hours, he can save a buck or two. So in this way, he can do his self-analysis, his behavioral analysis, and save money. So in this way, he can save his money and contribute to smarter planet, smart energy distribution. He can save some amount of energy. Next is the meter ping commands. The ping commands that are sent by the meter, these can be collected and stored to find out meters that are working abnormally. Example, they are the malfunctioning, or they not. If we have a particular range in which the meters are malfunctioning, the data is not coming on time, so there is some problem, we can go to the core and solve it. Next is outage management. This one feature is not there in the developed countries, but in developing countries and India, there is a huge problem. In the rural areas, there are power outages, more specifically load shedding, as it is called in India. For doing this load shedding, the utility company, a government company, what they do is they cut off power for the rural areas for 18 hours, and that is supplied to the urban areas. This is biased behavior of the government. So this can be changed. Using this, if the customer uses this smart meter data analytics, he saves energy, some energy, and that can be energy, small energy units can be saved by a particular customer. This together can be sent to the rural areas. So rural area people will at least not have 18-hour power cuts, that can be reduced to 14-hour power. Next, extending the data points. We have taken only the smart meter data. This data can be correlated with weather data also, the data from weather to analyzing patterns, how does weather, a drop in weather temperature or a rise in temperature, how does it affect the consumption patterns of the customers. Next is geographical location. As we have data from Ireland, the people in Ireland, it's very cold out here, so in winters they use more energy for heating. Whereas in India, the more consumption is done in summers because it is hot in India and more ACs will be running. Next is family consumption. This one point is interesting because we can find out patterns in such a way that if a particular family household are having children, they wake up at 6 in the morning. So during that range, there will be spike in the energy consumption. And whereas the old people, they wake up at 8 o'clock in the morning. So their work, they'll be using energy during that range. So this can be used for predicting energy more accurately to even the minutest details such as the waking up of the children. We would like to thank the Irish Social Science Data Archive for providing us with the data that we have for computing and the rest people. We would also like to thank the Yahoo and Hortonworks for organizing this event and calling us here to present our topic.